In this video, we're going to graph one period each of these two secant graphs. Here, y equals 1/2 secant of x minus pi fourths, and in problem number 2, y is equal to minus 2 secant of 3x plus 1. Well, the way we graph a secant function is by first graphing a related guide function, which is just its reciprocal function with all of the same transformations done to it. So the guide function in number 1, 1/2 cosine of x minus pi fourths. So let's go on and graph this cosine graph, and then we'll use that graph to generate the secant graph. We'll start by writing the amplitude, which is 1/2, the period, which is going to be 2 pi, the phase shift, I'm moving to the right pi fourths, and there's no vertical translation here. I'm not shifting up or down at all. So on this one, because the instructions just say to graph secant, I guess I could just try to use that information to graph secant, but I always like to draw my guide function with a dotted line. So I'm starting out here at pi fourths, and I'm supposed to end 2 pi later. So that's going to be out at 9 pi fourths. So let's see, 1 pi fourth, 2, 3, 4, 5, 6, 7, 8, 9 nearly equally spaced tick marks out there at 9 pi fourths. I need to know what's right in the middle of 1 pi fourths and 9 pi fourths, and that's going to be 5 pi fourths. And I always like to think about just adding those together and dividing by 2. So 1 pi fourth and 9 pi fourth would be 10 pi fourths divided by 2 is 5 pi fourths, and continuing in that way I get my 5 key points. For this cosine I'm getting ready to graph. Oh, I need to put some tick marks here on the y-axis. So we'll call that 1, so 1/2's right in the middle, minus 1 and minus 1/2. All right, cosine's waving around the x-axis here with that vertical translation of 0. And here's that cosine graph. Now that's not what I was asked for, that's my guide function. What I do with my guide now, where it's crossing its center line, well, that's where my vertical asymptotes for secant go. And if I think about that, where cosine is equal to 0, well, if I try to take a reciprocal to find the secant, that's undefined, and that's where those vertical asymptotes come from. Where cosine is equal to 1/2 here, secant's also equal to 1/2. And there are my nice reciprocal shapes. And that's my nice happy graph of secant of 1/2 secant of x minus pi fourths. All right, my guide function over here is going to be a y equals minus 2 cosine of 3x plus 1. The amplitude is 2. The period will be 2 pi over 3. My phase shift is 0. And we're moving up 1. So we'll start off the same way by dashing in our guide function. Start graphing at 0, end at 2 pi thirds with a 1 pi third in the middle. Half that and I find pi sixths. And if I just imagine what has to be between pi thirds and 2 pi thirds, well, if I add those together, I get 3 pi thirds or pi. This has to be pi over 2. Amplitude's 2, so I need 2 tick marks here. Cosine wants to start above its center line, but that minus out front tells me to flip it upside down. And there would be my guide function. And I get vertical asymptotes, but now I want to take into account that vertical translation up 1, but that wouldn't move my vertical asymptotes. And that's why we always say that our trig functions have vertical asymptotes, the secant graph is going to have vertical asymptotes where its guide function crosses over its center line. And so we'll repeat this process now down 2 units, thinking about all those nice lovely points I just plotted a moment ago, moving up 1. I usually wouldn't do this in 2 steps, but I thought it might be nice in this video to talk about why those asymptotes happen where we cross over our center line. Now I sketch in my secant graph exactly the same way we did before. And that is the graph of y equals -2 secant of 3x plus 1.